So we're on our last reaction. Reaction number 9 is going to be between hydrochloric acid and sodium hydroxide. We're going to use a new substance called phenolphthalein, which is an indicator. And remember that indicators change color according to pH. You might recall seeing this apparatus at the beginning of the year when we were learning about equipment. These are titration burettes. They have little valves and very accurately marked volumes for measuring out volume. If you do take chemistry in college, you will most certainly do a titration experiment where you take an unknown concentration solution and go back and forth with it to determine its concentration with something that's known. I'll try and explain it a little better here in just a second. So the first thing we've got is sodium hydroxide. It is clear and colorless. It looks like water. The second thing we've got is hydrochloric acid, 1 molar. Now these are both at 1 molar concentration, or supposed to be anyway. And so that goes into our special type of double displacement reaction. That's for acids and bases. And then phenolphthalein is also a solution, but again, it looks like water. There's nothing going on here. It's totally boring. If I put phenolphthalein in acid, nothing happens, but if I put phenolphthalein into the base, we get this crazy magenta color, okay? So that's our indicator. We're gonna start out with 15 drops of sodium hydroxide on the watch glass. Hopefully I counted correctly. We're going to put some of the phenolphthalein in there so we can see that it's quite basic. I'm going to put in more than 1 drop. It says 1 drop on the procedures. I'm going to mix that up a little bit. Just make sure it's evenly distributed throughout. So I just used a little wooden splint as a toothpick. And now I'm going to start adding drop by drop. I'm going to start adding the hydrochloric acid. There was 2 drops, and if you noticed, the area where the drops fell went clear, but when I stir it up, it goes back to pink. 4, again, clear, but distribute those ions around and it goes back to pink. 5, 6, 7, 8, 9, 10, whoop, ooh. So, I almost went too far. So that's 10 drops. Okay, it's staying pink. So I'm supposed to be able to go to 15. Let's see if that works. Whoops, that was 12. Darn it. Yeah, all gone. Okay, so I've gone past the equivalence point, it's called. I'm going to put another drop of sodium hydroxide in there and see what happens. It goes pink right around, but stir it up. Wow. Oh. That was a small drop. So that was 2 more. So one of these ought to take care of it because it seems like the acid's a little stronger. Yeah. Okay, so that back and forth then tells you that the pH is going above and below. It's the 7. So bases make it pink. And acids make it go away, make it vanish, makes the color go away. Let's see how that works. Boop. And the slower it goes, the better. That's when you're sure you haven't gone too far. There's really no temperature change involved either that I can discern on this. And that is our special type of double displacement between an acid and a base.